Welcome to Hack a Week, and that's exactly what I just typed out in Morse code on this little device right here, which I believe is a little practice unit for practicing for the novice ham license. Where did I get this? Well, this weekend I was asked to help a friend clean out their grandparents' old shed out back. Grandma and Grandpa are gone from this earth now, but it turns out Grandpa was a ham radio guy, I guess. Dabbled into it a little bit because I found all kinds of neat old electronics in this shed, and I was told that I could take them home in exchange for helping clean all this stuff out. So I'm going to show you some of the really cool stuff that I found this weekend, and I think you'll be really surprised that a lot of it still works. I know I was. So in the opening scene you saw this little telegraph device right here that has a simple speaker on it. There's a volume control for the phones out. This switch switches between the speaker and the headphones, and this switch routes it through that transformer for the headphones to impedance match it to the headphones, I suppose. And this is a little oscillator circuit right here made with a couple of transistors, capacitor, a couple of resistors. The whole thing gets powered by 4.5 volts, but I didn't have any D cells, so I just hooked it up to my cheapy bench power supply, and it worked. And so I thought it would be fun to type out "Welcome to Hack a Week" at the beginning of this video. You used to have to know Morse code to get your ham license. You don't have to anymore, but I still think it's a good idea to learn it if you're going to be a ham, because if you can't communicate with a microphone for whatever reason, it doesn't take much to be able to set up communication with Morse code. So that's that little device. Let's move on to some other stuff now, ham oriented. This was in the box along with a bunch of these. These are RF chokes, and each one of them has a tuning range 19 to 50 meters, and it looks like something plugged in right here, and then you connected this to a radio. And what this is a calibrator. It says so right there on this piece of phenolic material that this is built on. This is a handmade device. And then this big knob right here turns a variable capacitor, which is the way all radios used to be tuned, with a variable capacitor. Now it's done virtually with chips and whatnot. But anyway, that device is a calibrator. And I'm sure there's some ham people out there watching this. I know I have a few subscribers that are ham radio operators. So as this video goes by, take a few notes, and please do make some comments if you know about this stuff in the comment section below. There was also quite a few boxes of these. What's that? Hammerland for better radio precision products. Shielded RF chokes. And there's the code on them. And these things are kind of like the other RF chokes, but they are in a metal can. Oh, come on, I'm trying to one-hand it here with the camera. There we go. It's got an RF choke built inside of it right there. There was a lot of those in the box, and I suppose they were used for all kinds of things in radio. This is a neat old box of knobs and just all kinds of cool stuff like that. Tube sockets. And these are all Bakelite knobs. These are really neat. I'll probably use some of these on some future projects for a nice retro look. All kinds of neat stuff there. This box coming up here I thought was pretty cool. I love this handmade label, jacks, plugs, and switches. And that it is indeed. And these are some old ones. Look at this. Look at the way these things were built. These are like totally bomb-proof. Cool momentary rocker switch there. All kinds of jacks, more of those in here. Tube sockets. I love these switches. Some of these switches are really neat. In fact, one of these I'm going to put on my bass guitar because it needs a new switch. I ruined the other one. It's a little micro switch. I'm going to put one of these on because it looks really cool and it's rock solid. So, big old box of cool stuff there. Let's move on to some radios. Okay, first up, we've got this radio that dates back to the mid-40s. It's a World War II radio, and it's made by Templetone Radio Manufacturing Corporation. They were out of New London, Connecticut. And this particular model is the BP2A5. And what this was considered was a morale radio, or a day room radio, or just a radio for someone to listen to out in the battlefield, in between skirmishes, I guess, wherever they were, to stay in touch with the rest of the world via radio broadcasts. And inside we have this little section up here, has the service data cards in here, so you can tell what all the tubes are. And then on the back of that is a station log, and you could write down where it was on the dial, the call letters, location, remarks, etc. And I really love some of the stuff written on here, like turn off set when not in use, batteries are scarce. This thing ran on batteries, and it had a battery for the filament windings on the tubes. It was 1.5 volts, and then the rest of it ran at I forget, I looked it up somewhere, but a higher voltage anyway. And this one has an antenna that someone has in here wound up on a piece of cardboard. And let's see, I have it plugged in right now. I'm going to go ahead and turn it on. And of course it's tubes, so it has to warm up for a little bit. But it does work, but the only problem with it is the switch between the two bands, shortwave and broadcast. It has a rotary switch, and the rotary switches are kind of notorious for getting corroded. And as you can hear when I turn it, all that scratchiness. And if I play around a little, I can kind of find a sweet spot. There it was. Is that it? Where it actually starts to work. So it needs a bit of work on that rotary switch. It's a little messed up.
What we were talking about in the first hour.
Oh my God, it's that guy.
Republican.
So that's AM, also known as broadcast back in the day. And then this would be the shortwave band. But that scratchiness is a little strange. We can fix that. And I think I'll do that right now so you can kind of see what goes on in the back of one of these units. Let's put all this back. Close the lid down here in the front. Latch that back up. And of course unplug it. Unplug it. Wait. I thought I said it ran on a battery. Well, at one time it did run on a battery. But someone put this device in here, which was made roughly during the same time era as these tube radios. I'm going to use a screwdriver to pull this plug so I don't hurt the cloth-coated wires. But there it is. It was called the Perma-Power. It's basically a transformer, and it was a battery replacement transformer for these types of radios. And here's all the different types that you could plug in. This plug right here was the plug that determined whether it was a 6-tube or 5-tube radio, and you rotate it one way or the other. It's basically a jumper wire. So we can get that out of our way and take a look inside here. And there it is. There's the chassis right here in all of its beauty. I love these old things. They have an interesting smell to them too, old tube electronics. So this whole thing should just pull right out of here. There's some screws around the perimeter deep inside there, and I've already loosened a couple of them. Now I'll pull out the last two, and then we'll pull this out and take a look at that rotary switch and see if we can clean it up, make this thing work a little better. Well, as it turns out, I overthought that a little bit. There's just 2 screws on the front, and these knobs have to come off. So I have to turn the knobs such a way where I can get at the screws, the set screws that hold them in place, and then I can remove those like so. There's 2 screws on each knob. Okay, got one more right here. And there it goes. Now when I lift this off, everything should just stay right here on the bench. battery plug through the hole in the bottom. There we go. There is the chassis in all of its beauty. Look at that. All hand built, hand soldered. There's no reflow circuit boards here. This was all put together by hand. And there's a little note on the back that I kind of like. It's if you can see it here. Got this little thing that says to remove the fungicidal varnish from soldered connections before attempting to make repairs. So they have I guess that's fungicidal, yeah, anyway. They have that on there so that, I guess in tropical climates and stuff, fungus didn't grow on the terminals. So there's the switch that's all scratchy. This one right here, unfortunately it's all sealed up. It's not the kind I can get at easily without taking it apart, so I don't know about cleaning that physically. We may just go buy some contact cleaner, some electromotive type stuff, and give it a squirt in there and rotate it a bunch of times. Maybe we can get it cleaned up and get this radio working the way it should again. But I had it working the other day and got some shortwave broadcasts on it. Pretty neat piece of World War II history right there. Okay, I've got that scratchiness a little better. Got the shortwave side working. And right here I picked up a couple of amateur radio people. Barely. Can't really understand them, but when I was a kid I had access to a shortwave radio and I would sit for hours slowly turning the dial trying to find these guys and listen to them talk, and I found it fascinating. And there's a lot going on in the shortwave bands. When you turn this knob, stuff just goes flying by. So there's a lot of time spent just slowly turning the knob and listening back and forth, back and forth. And if you found a place where people routinely talked, you would log it and write it down, what time of day it was, what frequency. And sometimes you could come back 24 hours later, people would get together about the same time every day, and you could listen in on their conversations. Kind of like an early internet. But there's a whole lot around the 31 meter bandwidth. A lot of religious stations I pick up here. They come through very loud.
Another way is call if you have access to the phone. My phone number is
information.
Oh.
Make sure you complete it. And by
There's some more there. So, anyway, cool old shortwave radio that still works. And I think that's really awesome. I need to get an outside antenna connected, and I can probably get out here and have some fun in my spare time playing around with shortwave again. Near and dear to my heart. I got my start in electronics with the help of some mentors that were ham radio operators. Okay, let's move ahead a little bit in time into the next radio we have to check out. Next up we have another shortwave and broadcast radio from National, and this one is the model SW54, SW for shortwave. This one here has a few bands on it. You can see right there. We've got police and ships, amateur radio, foreign broadcasts. Of course, some of that doesn't quite apply anymore with the police bands. They've changed a few times throughout the years, mostly VHF now and also other frequencies. Anyway, this, when I first turned it on, it lit up, everything worked okay, but the selector right here was pretty scratchy, and it didn't do very well as far as being able to select between the bands. It was always a little bit intermittent, kind of like the one we just looked at. But after a bit of work, I got this working. Let's take a quick look at what I did to get that to work. So as you can see, it just took taking it apart and cleaning those contacts a bit, and as you saw in that little short segment there, the whole chassis of this thing is copper clad. It's pretty cool. Some people have restored them and actually polished up that copper clad chassis. Well, let's see if we can hear anything here. We're now on C, ABC. We're on the what's called the police band, I guess. Data broadcast. Of course, those religious broadcasts come through loud and clear. Plenty of those. Let's check out the first band here, A. That would be the foreign broadcasts. Don't know if there's really going to be much show up on those anymore.
Well, his name was same old Republican rich guy.
Politics. This has got a real nice feel to it. It's a direct link tuner. And then some radios had a main tuning knob and then a fine tuning knob. This one kind of does it over here with a larger dial, and you can spin it fast here and then fine tune. So let's try another band. Not much going on there either. Give it a quick sweep. If there's any stations, you'll hear them blip as they go by.
Amen. Lord John.
Used to hear lots of teletype transmission when I was a kid. Has a very unique sound. And you would hear Morse code a lot more. I have yet to pick up any Morse code on here at all. Used to hear that a lot. Let's try the other band here. Well, not too much there. Haven't really picked up any foreign stations. Of course, I would do a lot better if I had an outdoor antenna. As it is now, I just have this single lead here that just goes nowhere. But if I had an antenna outside actually tuned in to the frequencies I would want to receive, a given length of antenna equals a certain frequency it will pick up, and I did quite a bit of that stuff as a kid. So anyway, that's the National SW54. Has 5 tubes in it, and it was a pretty popular radio in its time, made between, what was it, 1950 and 57. So this is a really cool piece of vintage electronics to have in my collection. Let's move along now to another one. Now this is just a simple Zenith AM radio, tube driven. In the back there are some tubes here. And I love the stuff on these. I just love the way they laid these out in the past. It says that it has a filter magnet antenna. That just sounds really high-tech and cool, doesn't it? So let's take a quick look in the back here. I've removed the screws ahead of time so that I can just lift this off and show you. And it used to be very commonplace that every single device you bought came with a tube layout, so you knew just which tubes were what and how to replace them. And quite often there was a schematic on the inside, and this one probably had one right here, but it's gone now. So here it is in the back. This particular one is not working at the moment. More than likely it's a problem with this transformer, because I have power coming in, power going through the switch, and I think this may have a problem, or it could be some circuitry in here. I can put a tube in one of these sockets. I forget which one. There's one of them that was burned out, and when I put the tube in, I have some spares that I found in another box. The filament lights up and glows extremely bright and then burns out. So that was the one right here that's missing. It just burned out. So anyway, that's the back of your basic 50s, 60s desktop AM radio. Next up, one of my favorites of all time, the clock radio. I had lots of these as a kid. It was surprising how many of them I could get from people. I used to go knocking door to door when I was about 12, 13 years old and got interested in electronics. And whoever would answer the door, I would politely ask, "Hi, my name's Dean. I'm interested in electronics and I would like to experiment with any junk electronics you might have. Do you have any old radios or TVs around that you want to get rid of?" Quite often I would get 2 or 3 of them handed to me on the spot, and a lot of times it was this style of a radio, usually a clock radio. They had tubes in them, and often it was just a tube that went bad. This one turns on right here, and it also has like a sleep setting. You can turn it on and listen for anywhere from 0 to 60 minutes and it would shut off. And there were plenty of nights when I was a kid I would fall asleep listening to my tube clock radio. So as this is warming up here,
1,500 such grants to be made. 30,000 people
AM
showed
station
up.
there.
And our affiliate, WJR, sent a report.
That nice warm tube sound happening.
Some various questions. Why
So
are they there?
let's turn it back off here, and we can let's set the alarm, and I'll show you what the alarm on these things sounded like. It's set for 7 o'clock right now, and I believe in the back here is where we can turn the time ahead. So let's turn the alarm on, put it on auto, and let's move around to 7 o'clock and see what kind of noise we get. Oh, I heard it click, but I think the buzzer is no longer working. Either that,
Assessment or
it
abatement. Obama was going to.
it did it with the probably with the radio. Let's try it again. Put it on auto, and we'll spin around to 7 o'clock. Yes, indeed, it's the radio that comes on.
And that's what people thought.
So this one didn't have a buzzer. It had the radio that woke you up in the morning. So there's another one. This is a General Electric, and let you take a look at the back here. This is interesting too. It had a timed outlet, so you could drive another 110 volt device off this from the actual timer built into this thing. And right here is a phono input, so you could actually hook up your phonograph, your monaural phonograph, to this and listen to it through your clock radio. There was a time when this was a really cool state-of-the-art device, probably sometime in the late 50s, early 60s. Now as we moved ahead into the 60s and 70s, we started to see a lot more of this type of clock radio. This is a General Electric transistor clock radio. And of course it comes on instantly, and because it's transistor circuitry, dramatically shrunk the chassis size. This one is just a simple AM tuner, and it also has the same features as the other one, a 60-minute sleep cycle, and the auto or alarm feature. Now this one probably did have a buzzer. Let's put it on alarm and advance the set the alarm there, and then we will turn the time and see what kind of sound we get. Oh, okay, it's the radio, just like the other one. Wake up to music. Okay, so that's a transistor model, considerably smaller. So with the use of the transistor in electronics and being able to shrink things down, and not only that, run them efficiently on battery power, started to get a lot of these type radios, portable AM transistor radios. And this one is a 8 transistor radio. Some of the marketing hype on these was kind of bragging rights about how many transistors were in the thing. So they would actually put it on the device, like this one right here. It says on the very front, high sensitivity, 8 transistor. Whoa. And this one is made by Luxtone. Rather handsome looking. And it was portable, and it ran on 4 C cells. This one's not working at the moment either. I connected it up with the bench power supply and I get nothing, so it's probably got some faulty transistors in it. But I believe these are all JFET transistors in there, which my cat would really love. There's 1, 2, and there's going to be 6 more in there somewhere. And things got smaller and smaller with those. And here's a typical 70s Radio Shack version of a little transistor radio. Runs on a 9-volt battery and could be easily carried in a pocket. AM only, not FM. That came along later. Of course, the 70s was the decade that the cassette came into being. Cassette decks like this. You put your cassette tape in there and you had a built-in AM and FM receiver here. Let's turn the radio on. And FM radios came with their own antenna, which we have right here. So you could record off from the radio. I did quite a bit of this as a kid. I had one very similar to this. Have a volume and tone control. Had a rotary control here for rewind, stop, play, fast forward. Even had a level for the battery, so you could tell just how much time you had left on your portable device. And you could carry this around with you. Ran on some D-cell batteries, or you could wind the cord up, the AC cord, in the back and stash that. Well, that's about it for the radios. Now we move into some really cool test equipment that I found. This is made by Allied Electronics. They started out as Allied Radio in 1928, and they were around basically to sell electronics to amateur radio hobbyists and whatnot. Initially they were supplying manufacturers with parts, but then they started to sell to hobby people, mostly amateur radio people. And they made lots of electronics during World War II, which is where they really ramped up and kind of cut their teeth on industrial electronics. Now after that, during that time is when they turned into Allied Electronics. They were called Allied Radio in 1928 when they were founded. Eventually they were bought by Tandy Corporation in 1971, which is now Radio Shack, of course. And they made kits during the 50s and 60s and 40s called Night kits, K-N-I-G-H-T, similar to Heathkit. This is one of them. This is the model KG625VTVM. It's a volt-ohm meter. You know what? It still works. It's really tricky to get calibrated. It has a tube in it sitting right here behind the meter. So it's best to plug it in, leave it on, and let the tube warm up fully. Then go ahead and do your calibrations and get everything dialed in the way it's supposed to be in order to work properly. So I've got a 20 ohm wire wound resistor here, and right now I have this on the R×1 scale. This is not auto ranging. This is when you had to actually dial it into the range depending on what kind of ohm reading you were getting. R×1 means you just basically look at that reading and multiply it by 1, and that's how many ohms it is. So this is a 20 ohm resistor. Right there it's reading 20 ohms. Now if I were to go to the ×10 scale, it drops down and it's roughly around 2, and I would multiply that by 10, of course, and get 20. So that's the ohm side of everything there, and the volts actually still do work as well. Let's check a little rechargeable battery here, see what we get. And there it is, about 1.5 volts DC reading on this scale right here. So that still works. That's pretty cool. That's a neat old device. I kind of like that it's got a tube in it, and tubes are best left on all the time on devices like this because they will go way out of calibration if you turn it off, turn it back on, and then try to use it again. A brother I have that was in the Navy working in sonar told me a story where they calibrated and set up the whole sonar system ready for an inspection, and it was all tube driven, all the electronics running off batteries. They had it all calibrated, spent a whole day, it was working perfectly. They shut it down the next day when they had their inspection and fired it up. Everything was wacky and they totally failed their inspection. So tubes are best just left on. The thermal cycles are harder on them. If they just stay warm all the time, they tend to last longer and stay in better calibration. Let's move on to the next thing. Okay, here's another one from Night Kit, and this one is a in-circuit capacitor checker. This is probably my favorite find of all. This and the shortwave radios. This thing is really cool the way it works. It has a an eye here that I'm pretty sure is a vacuum tube because it does take a minute to warm up. You'll see that it'll turn green in a minute as it gets fully warmed up. Let me find a capacitor over here to test with. And the eye will tell you what's going on with the capacitor. Right here it tells you eye indication remains open, the capacitor is defective. If it closes, the capacitor is good. So let's connect up this 1000 microfarad capacitor, negative to the negative side, positive, whoops, to the positive side, of course. Now watch what the eye does right there. Oh, it didn't do anything. Oh, I have to put it in test mode, that's why. There we go. You can see how the eye goes closed or remains open. Let me zoom in on that for you. You can see it in all of its green, glowing glory. That is really cool looking. It's like the HAL 9000, whatever. So you can see how it changes there. Get it in shadow, maybe it'll show up a little better. There, it's open. So you can also check for a short in the capacitor as well. And if it goes open, it's good. There is no short. So you can use this to test capacitors in the circuit. You don't actually have to desolder anything. You just hook it up in the circuit and test away. And here is another box from Night Kit, and this is a capacitance substitution box. It goes all the way from 0.01 to 0.0068 microfarad. So we could put this on the 0.1 setting, and we could test it out with the checker. And it doesn't quite go all the way closed, so there may be some capacitors in there that are a little bit leaky or worn out. Now see, that one shows okay. Some of these other ones don't. Pretty cool stuff. Night Kit. Been a lot of fun playing around with these old shortwave radios and electronics. I'm really glad I had the opportunity to help my friend out and end up with this really cool stuff. I really think I will put up some outdoor antennas because this has reignited the radio bug that's in me and has been for a long time. I'd like to thank all those ham guys from my past for being mentors for me, and any of you ham people out there have any comments on this, please feel free to put them down below in the comments section. I'll probably do a little update later on, another video down the line as I get some antennas up and maybe get these working a little better, and we'll talk about them a bit more. My friends, the toy makers, TYMKRS.com, they do quite a bit of stuff with ham radio, a lot of stuff on their blog, and one of them even has a ham novice license, so how about that? Go check out their stuff. They do some really neat stuff. That's TYMKRS.com. And since it's the new year and I've wrapped up nearly another year of hacks, just like to say thanks for watching. If you like the stuff I do, you can donate and help me out. It does cost me some money to do all this stuff all the time. So if you feel so inclined and you want to donate, go to the donate page on hackaweek.com, and the link is there. Do what you can do. And if you just want to keep watching and you can't donate or you don't want to, that's fine too. You'll just learn something, and I enjoy doing them anyway. So, till next time, keep on hacking.